Route tables are used to determine where network traffic is directed. So here is an example of a architectural diagram, and we're representing the route table. In a lot of these VPC uh, diagrams, a lot of times the route table would be left out and the router. And oftentimes, if the route table is in the diagram, the router is just not present in the diagram, but I'm showing it to you so you know there is something there. The router is not something that you have direct access to, so that's why it's never shown because there's no need to. But I just want you to know that there obviously is some kind of component because a route table needs a router to route things, right? Often, not often actually, but the initialization for route tables is RT, and I'd say I rarely, if ever, see that used, but I have seen it before, so I'm listing it there just in case. A route table contains routes. You can notice that we have a destination and a target. So those are two things we'll talk about here shortly. The most important thing is that route tables are related to subnets. So each subnet in your VPC must be implicitly or explicitly associated with a route table. A subnet can only be associated with one route table at a time, but you can associate multiple subnets with the same route table. So the route table is really associated with subnets here, and that's how you're going to tell what to get access outbound or go somewhere else. We have the main route table. This is the default route table created alongside your VPC, which cannot be deleted. A subnet that is not explicitly associated with the route table will use the main route table. This is good, but it can also be bad if you have a resource that you don't want to go out to the internet, which the main route table will be associated with. You can see which is your main route table in the list of route tables because there'll be a column called main and we'll have one called yes. So here's a diagram of the main route table being used, and it's going out to an internet gateway, and it's associated with some public subnets, the default public subnets that are created with the that are part of the default VPC in your area. There are use cases for having custom route tables. A great use case would be if you need to pick very specific subnets. And they are going to go out to very specific things. So, like a very common use case would be out to a VPN or something that's not an internet gateway because it's a private connection or there's a security third-party appliance or something. So, just understand that the use case for custom route tables really comes into play when you're doing things other than an internet gateway, if that makes sense. For destination, this is where the route will go. Here you can specify the IPv6 CIDR block or the managed prefix list. So if you were going out to the internet for IPv4, it would look like that. If we're going out to the internet for IPv6, it would look like that. If you wanted to specify a managed prefix list, which I believe would mean any, this would allow for anything to go to a DynamoDB table that is in US East 1 in any account, not just yours. That's what managed prefix lists do. That's something that you could do there. The other thing I want to cover is targets. So earlier in the slides, I'm just going to go back here for a second, but we talked about, or we said that there is destination and target. This is a bit confusing because I kind of wish it was like source and destination, but I'm sure there's a reason for it. The networking folks can tell us why. But let's cover what targets can be used because it is important to know the targets. Not all of them for the exam, but it just gives you a better understanding of the utility of route tables when you can see them all here. And it was a bit of work to round them up for you here because they don't make it straightforward in the docs to get them all. So target will have a local. This is the default local route. You cannot delete this route. It will always be present. This is so that your subnets can route to things. If you didn't have a local route, your subnets would not connect to anything else. And so we have to have a local target. You have your internet gateway. So this is for ingress and egress traffic for IPv4 and IPv6. You have a virtual private gateway. This is for private connections to an on-premise network. You have NAT gateways. This is for egress connections for private instances out to the internet for IPv4, specifically IPv4. The reason it's not for IPv6 is because IPv6 doesn't need network address translation, which we'll repeat many times in this course because IPv6 addresses are public, whereas IPv4 are not, generally known to the public. So network address translation is required for that. We have an egress-only internet gateway. So this is interesting because IPv6, all the addresses are technically public. They actually have to have this special way of if you have private instances, to go out to the internet but not allow public access. And so we have this egress only internet gateway, which we talk about at some point in this course. You can specify a specific instance that is allowed to send traffic out via route, so a very specific EC2 instance, or a network interface, an ENI, for a specific Elastic Network interface. You have carrier gateways. This is out to AWS partner telecom carrier networks via AWS Wavelength. This is what I have to assume because carrier gateways is associated with AWS Wavelength, which is for those telecom carrier networks. We have core network. This is out to a managed wide area networking. So that's WAN, W-A-N, and this is specifically via AWS Cloud WAN. We have gateway load balancer endpoints. This is out of a gateway load balancer, a GWLB, and GWLBs are for third-party virtual appliances. This is when you want to bring your own virtual appliance, or maybe it's probably like a list of very specific ones, but the idea is for additional security stuff in your network. We have Outpost local gateway, so this is out from I keep saying to an, but it's actually from a Outpost, a physical server rack with an AWS service in your own data center, a peering connection, so out to another VPC. And then we have transit gateway, so TGW, out to a transit hub for connecting multiple VPCs and on-premise network. Now, the reason I really want to list these over is in this list here is because I want to repeat this stuff again and again and again, because there's so many little weird networking services, and any opportunity I can repeat it when it's being used somewhere, I'm hoping that you'll remember what this stuff is. You'll definitely see a lot of the stuff when we cover gateways, but yeah, that is route tables. So there you go.